Okay, hello everyone. My name is Amir Shabar. I'm the chair of the Toronto Center of CMOS. So today's speaker is Qian Li. She began her career at Environment and Climate Change Canada in 2002. She holds a bachelor degree in meteorology from the Department of Geophysics at Peking University and a master's of science degree in synoptic dynamics from the Chinese Academy of Meteorological Sciences. Wen Li is the Science Liaison Officer at the National Radar Operation at Environment and Climate Change Canada. She joined the Canadian Weather Radar Replacement Program in 2017 and has been actively involved throughout the implementation phase. Our contribution began just prior to the commissioning of the first new radar system in Radisson. As a science liaison officer, Wayne coordinates key activities among various stakeholders, including the radar manufacturer, radar research scientists from science and technology, and radar data integration team, as well as radar user group. So today's topic is the new weather radar network from project to operation. So over to you, Gwen.
Hey, thank you very much, Amir, for inviting me to give this informal talk to the CMOS community. I saw some familiar faces, my old managers, so very glad to see you here. So good afternoon and good morning if people are in different time zone. Yeah, so I don't want to introduce myself anymore. So I'm still serve as a science liaison officer within the National Radar Operations. So my key role is still collaborating some of the improvement to the radar network. So working closely with S&T radar scientists and the data processing team from CMC, as well as the radar users group. So yeah, so the radar replacement project and ongoing operation could not have been possible without the contribution of all the other teams across Environment Canada. So I'd like to acknowledge their work and contribution to the work in this presentation as well. Today's talk, I will begin with an overview of the radar replacement project, followed by some key differences between the old and the new network, and then highlight some technical features and their benefits. I will then showcase some example of new products from the updated network, including scan strategy and data quality improvements driven by our S&T folks. And then finally, I will give a brief discussion about priority challenges and future consideration. So the radar replacement project was officially launched with a Gate 2 approval, Treasury Board approval in 2016. So the first site acceptance was took place in December 2017. I joined the project in October 2017. So I was in the commissioning stage of the first radar at Radisson. So that's about 18 months following the contract was awarded. And then year 2, we installed 2 radar. After that, it was a 7 radar per year pace. But the pandemic introduced tremendous challenges to our project. Ultimately, we will overcome all the challenges through great teamwork and a common goal to success. We do have exercised the 1 project option year. That's because some of the supply chain issues and also the real estate for some relocating site, we have experienced a longer than expected time to get the land approval. So the last two sites, two systems installed were completed in August 2023, but that's only 5 months past the original schedule set in 2016. So overall, the project included replacing 26 obsolete radars, relocating 5 sites, including 2 radar that was previously owned and operated by the National Defense. We also added 1 new radar in the lower Athabasca area and 1 new non-operational radar dedicated to the testing and training purposes. Beside that, the project also included upgrading data infrastructure and adapting process software applications. So that include URP and NINIO. In terms of technological differences between the old C-band radar and the new S-band radar. So as you can see on the table, the C-band network had 3 types of antennas, comes from different time period. The angel antenna provided with the best, the fine beam width, which was great for sensitivity and especially for detecting snow.
We're not seeing your presentation if you wanted to share your screen.
Oh, I didn't, sorry. Okay. Let's see. Forgot to share my screen. Share.
At the bottom, you see a share button.
Yeah. I tested before, but I forgot this time. Okay, I hope you can see my screen now. Or is it coming?
We can.
Yeah, we see it.
Thank you.
Okay, thank you. Sorry about that. But you didn't miss too much. In terms of technological difference between the old C-band and the new one, the C-band had 3 different types of antenna. And the angel one is the best, give us the highest sensitivity for detecting snow and shallow weather. We also had 1.1 degree antenna from even older generation that were manufactured by Enterprise and Raytheon. The new radar have the largest possible antenna fitted into the radomes, that resulting in a good sensitivity and the beam width. So as you can see, the angel antenna, the beam width is 0.62 degree, and the new antenna is about 0.88 or 0.89 degree. So the signal processor was changed as well from Vasila segment RVP 708 digital signal processor to Leonardo's GDRX5. And then a significant selling point at that time was the renewal process was to reduce the maintenance and site visit from 6 to 2 visits per year. Although we haven't fully achieved this object yet due to some remaining challenges, a lot of them are related to HVAC issue and some other issues. And there's a deep learning curve for us as well. It still reflects the level of ambitions we are striving for. In terms of Doppler range, it has extended from 120 kilometers to 240 kilometers, which I will speak to it later on. So this is a typical look for a radar site. All Environ Canada radar are carbon copies of each other. So they have a same technology, same design. The only difference between radar is the height of the tower and the specific frequency assigned to the radar. So the new radar features a 9.1 1.15 meter parabolic antenna inside almost 12 meters radome. And then the main shelter, radar shelter, are located just below the radome. You can see here. And then there's a ground shelter, which hosts the electrical equipment, the network cabinet, phase converter, and some servers for radar data acquisition. The radar shelter is hosts some of the, the brain of the radar. It has the transmitter, receiver, waveguide as well, goes up to the radome. It has, the analog digital receiver are all located inside the radome. So we also have a all-in-one integrated weather station. This is not used for, for the climate or weather per se purpose. It's mainly for the technician to know what's the situation at the site to help diagnose some of the issue of the radar components. And also the new radar has extensive lightning protection. Okay, so I think most of you already know this. So the radar comes with a dual technology. The left side is a single polarization radar, transmit and receive radio waves with a single horizontal polarization. And the right one is a dual polarization radar, which transmit and receive in both direction. So with that, we now have a dual products that could help distinguish between different type of precipitation, which I will speak to it later on. So the dual data currently being sent out are ZER, ROHV, 5DP, and also KDP. So as I said before, despite dealing with supply chain hiccups and other challenges, so we managed to pull off this project almost on time and within or under budget. We now have this new network, and the new radar comes with 4 times higher power than the old ones, which means much more sensitive. And then the new dual technology helps to deliver higher data quality to our forecast services. Then this means our weather warning will be more accurate and effective because we have now 6 minutes of refresh time compared to the 10 minutes with the old network. As I mentioned before, the Doppler range also changed from 120 to 240. That gives a bit of overlap with neighboring radars for better business continuity. So with the installation at final commissioning of the Half Moon Peak radar, which is a relocation from Mount Seeker to Half Moon Peak area, along the North Street of Georgia, in the Sunshine Coast, BC. So that one was completed in August 2023, the last radar. So now we have a 33 dual polarized S-band radar system with 32 in operation. So all the radars are owned and operated by ECCC. The key differences, as I already mentioned before, is the extension of the Doppler range from the old 120 to 240. And that was one of the key requirements by the forecasters, was to increase the Doppler change. The initial submission, we request to increase the footprint of the radar network, but that was not approved. So we cannot change the footprint of current radar network except for adding just one new radar. So the possibility is to extend the Doppler range with the new technology. So the map just to show the Doppler coverage with the old coverage shown on the left from 2016 and the new coverage on the right. As you can see, the population coverage has increased from 85% to 98% of Canadian population. I want to mention is in 2023, we have made some change to the scan strategy to extend the conventional coverage from 240 kilometers to now 330 kilometers. So with that increase, over 99% of Canadians are within the range of a new radar. Before we move on to improving data quality, just for those who are not very familiar with radar, so I'd like to briefly discuss what it means for radar data. So this chart visually represents various physical artifacts that affect radar data that must be addressed to ensure, usage of the radar at a different for different user community. So the first one is the terrain blockage. So either total blockage or partial blockage that will affect the radar data quality. This one shows the second trip echo, which occur when radar pulses reflect back from a distance object beyond the expected range and causing false data echoes. And then we have attenuation and beam filling. So that refers to weakening of radar signal as they pass through heavy precipitation. The S-band radar has advantage for the attenuation effects compared to the C-band. So it has less attenuation compared to the C-band network because of the wavelength change. Broadband. The broadband and effect occurs when melting snow reflects, or a melting layer, melting snow reflects strongly, appearing as a heavy precipitation. And then, of course, we have the RF interference from nearby equipment like telecommunication towers and equipment that operated to the similar frequency as our radar. So yeah, that one caused a lot of issue with our S-band radar, which I will talk about it later on. And this is known, all the near radar ground clutters, the trees, insects, and the plants, buildings. So those are all ground clutters that need to be dealt with. And we have anomalous propagation as well. So that's due to atmospheric condition change and leading to some false echoes. Wind turbine is another increasing concern. That's a global issue. So we have a team here to deal with the wind turbine and have set up some rules or regulation. But not legal regulations, just guidance to help with this. Okay, so now shift to focus to the products. Particle classification is one of the key products from the dual-pol radar. So the left panel is the corrected reflectivity from a Blainville radar in the Montreal area. So which you can see the higher reflectivity value, the red and yellows typically indicate a strong precipitation, such as heavy rain or even hail. The right panel is the particle classification. We call it PARCA, which clarifies the type of particles detected by the radar. So each color represents different types of particles. For example, the red indicates hail or mixed with rain. Green indicated rain or heavy rain. Blue and light blue indicated wet or dry snow. So this product is super useful because it helps us with a differentiate between a different type of precipitation. Another product from the new radar is the duple corrected quantitative precipitation estimate, which we call it DPQPE. So the left one is the raw reflectivity in dBz. The high reflectivity value is, warm color, yellow, orange, red, suggests area of intense precipitation. And you see there are a lot of residue clutters remaining. Even though at the radar site, we already put some basic filters, you can still see ground clutter. You can see the RFI radios from the site and the wind farm here. And the right side is a duple corrected quantitative precipitation estimates. So you can see all the clutters. It's much clearer. All the clutters and wind farms, the RFI radios are gone. The downside could be where it removed the ground clutter, it also removed some weather signal. So as I said before, the new radar with extended Doppler coverage greatly enhanced the storm tracking for severe weather detection and early warning capabilities. So this example shows a multi-cell thunderstorms occurred in Quebec, from the San Francois radar in Quebec. So this one, this event was captured with multi-cell thunderstorm and 2 EFO tornadoes in 2021, in June 2021. So the yellow ring indicated the previous Doppler coverage, which is 120 kilometers. The red rings indicated the thunderstorms, cells or thunderstorm signals. So with that extension, we were able to see more from the radar. So that could give us some lead time or more area to observe the phenomenon coming through. I've mentioned about the RFI multiple times. So that's one of the challenges we're facing in terms of data quality. We have more than 10 sites that we saw RFI radios from interference. So some of them are very severe. So as you can see, the index, we put the impact score in the table here. King Radar, Franktown, all the big cities, they have multiple cell towers close to the radar sites. So since the first one installed at Blainville, we started to see this type of contamination, and that's more severe compared to the CWRN network. So we have developed the RFI investigation process, which include recognition, evaluation, reporting, investigation, and mitigation. So during the project implementation phase, we have submitted 12 requests to Industry Canada to investigate the potential source of RFI at this sites. And then they have investigated 3 of the 13 sites, but they concluded that there's no misuse of the allocated spectrum. But the coexistence of a communication tower and weather radar in very close proximity has been identified as a source of receiver. Intermodulation, so that causes RFI interference in certain S-band weather radar system. So to address this, our engineering team partner with a manufacturer to design some customized receiver that can be installed on the receiver side to mitigate the contamination. In the past years, we have tested those filters at more than 10 sites and approved that it was very effective. So last year, a change request was approved to install those filters at 10 operational radar sites. We have done 7 of them already. There are 3 still remaining to be installed. So on the screen, you see is the filter installation at, I think it's Landview radar site. The left one is before the filter installation, and the right one is after the filter installation. So as you can see, nearly all the alpha interference radios have been successfully eliminated. So this approach is better than using software approach. When you use software approach to get rid of those radio, you may remove the weather signal at the same time. Of course, the downside of this is insertion loss. So we've tested multiple times to try to get the lowest insertion loss from the filters. So right now, the insertion loss is less than 1 dB. Since our radar is very sensitive, so 1 dB loss is not a big deal from the evaluation. Wind turbine is another source of contamination due to the rotating blade. So this presents an increasing issue to our radar, to our S-band radars. So on the screen is an example of wind farms located very close to the braid radar. So that caused high contamination to the radar signal, as well as create a multipath contamination as well. So Environment Canada is revisiting his guidance for wind farm proposal. And this is still under review. Yeah. So this diagram illustrates a completed radar data flow starting from radar acquisition at the S-band. So we have raw data in rainbow format. There are 10 moments, and we get 40 files every 6 minutes. 3 azimuth file at a different elevation and 1 volume scan file. And then the data were sent to our one of our key data center and distributed to regional URP and then national URP for processing, and then further distributed to our external and internal clients. Now shift gear to the use of data and the contribution from our S&T team. So that from our S&T team during the project phase, they offered invaluable advice, guidance, and recommendation on the infrastructure design, the data acquisition, scan strategy, and data quality assurance. So start with the updated scan strategy. So in 2023, we expanded the scan strategy. We call it PBOS 6S to cover a range of 330 kilometers. So with the extended range, the elevation is still 17 elevations. And then at 240 to 330 kilometer range, half the data is interpolated from 0.5 to 1 degree ray. So the range step is 500 meters, and the azimuth stamp is 0.5, except from the range 240 to 330 kilometers. And then last year, I believe, these products was publicly available. this is a surface precipitation type products at national level, and that involves processing 1 kilometer PACA data, compositing it, and then integrated it with the wet bulb temperature from one of our NWP models. So this combination result in a detailed surface classification categorized into different classes. And then moving down to the network operations. So the network priority and challenges focus on 4 key areas. The first one is maintenance and reliability. So because the network is fairly new to us, regular preventive maintenance, data management, and lifecycle management, they're all quite new. So a lot of things are under development. We have to deal with some of the long lead time parts, and then keep communicate with vendors on the dependency required for planning. And then the third one is data quality and calibration monitoring. So we have ongoing monitoring of calibration drift, clutter, noise, some of the dual polarization challenges such as ZDR biases. So that's the data quality part. And finally, there are geographical and environmental factors. Some of the mountain sites are hard to access, and there are they propose some challenges for maintenance, so this is something we have been dealing with as well. And then currently, this fiscal year, we are upgrading the network server and software to include additional parameters that enhance our ability to monitor system performance directly from the raw data. We are, as I said before, we are installing RF filters at 10 sites to reduce radio frequency interference, contamination. And also we're developing new tools to improve system monitoring. So that's currently the radar operation section is working on. I believe that's the last slide from me. Thank you very much.
Okay, thank you very much for bringing us up to date on the new radar system. So I open it up now to questions for the speaker. Unmute your mic, please, before you speak. Well, doesn't look like there are too many questions, but I have a few. I noticed that the coverage in the north is lacking. Is there some plan to bring some radar site in the north as well?
In our original submission, I think we proposed a few radar site in the north, but it was not approved. So we were told not to increase our current footprint. I think there are some ongoing discussion. S&T, in fact, maybe submitted some proposal in previous years, but didn't get approval.
Mm-hmm. And also, you mentioned the distinguish between liquid precipitation and snow with this new radar. Does it also do something for the freezing rain? Does it catch freezing rain bands as well, or no?
Yes, yeah, because the freezing rain, they have a different, the particle or the drop have a different size and shape, so it can characterize freezing rain as well, and crystal particles.
Okay, and my last question is, have you seen any improvement in the warning and watches, issued by the Weather Center, does it, is there any change because of this new radar network?
I haven't seen any evaluation report, but with the increased refresh rate of 6 minutes of scan time, I think there should be a little bit more lead time than before, but I haven't seen some quantitative analysis from this.
Okay. Okay, well, looks like there are some questions. Let's see. There's a question here from Leslie Welch. The province of BC has recently approved several new wind energy farms, but crucially has exempted them from environmental assessment. Is this procedure likely to reduce the chance of voluntary guidelines being affected?
Several wind farm energy farm. I think the current guideline is there's no build guidance within 10 kilometers of the radar site. And then if the radar is within, the proposed wind farms is within 50 kilometers of a radar site, they have to send a proposal to Environment Canada for review the impact. And then I'm part of the reviewing team. I think I saw the proposal from BC. Once the evaluation deemed that the impact is manageable by the forecasters, because the forecasters, they are the final level of reviewing for the proposal. If they're saying okay, then we would let the proposal go ahead. But if it's too close to a radar site, we would recommend not to. So I don't know what's the distance of the new proposed energy farms.
Okay. The next question is concerning the cell tower interference.
Mm-hmm.
How does the new radar deal with that?
Yeah, as I said, the new radar has experienced more RFI interference, mainly from the cell tower equipment. So in the past, we have discussed with Thales, with Bell for this, and they are, if they try to propose a new cell tower close to our radar, they have to submit it to the consultation process, and Environment Canada has a say to this new proposal. But with existing cell towers, our RFI filters worked pretty effectively to mitigate those contamination.
Next question is, how does the integration with the US radar system for product generation work? How do we integrate that?
Yeah, the the CMC's remote sensing team is doing the integration. So right now, level 2 data from NextRad ingested into our national products. Also in the regional products, they are processing US level 2 data as well. So it's already integrated with us. But there might be differences with different radar. Maybe you can see some radar, they'd be hotter on the US side or on the Canadian side. So in terms of a radar comparison, I don't know if their process to address this. But the US data were ingested into our system already.
Do they have a similar technology as this new radar system?
The US radar?
Yes.
They have the same technology, S-band cholesterol radar, different signal processor, different data processing system. So they have their own signal processing system built in-house, and ours for data acquisition, we use a commercial software from the vendor. So it's a remote server we use at the site to acquire radar data to generate radar moments. We use our in-house URP application to process the radar data. So hardware wise, a lot of them are similar.
Okay.
Yes, I think it's better to ask cell
Yeah.
tower.
Cell tower radar signature. Okay. I don't know exactly what the question is, but maybe
You want to start audio to ask, so maybe you can turn on your mic.
Yeah.
So can you hear me?
Yes.
Okay, thank you. It's Paul Beckwith. I do quite a bit of storm chasing both in Canada and the US. Like I've been down for tornadoes about 5 or 6 times. So I'm very curious because when the new Canadian radars came in, those I guess it turns out that it's cell phone tower interference when you get a line at a certain angle from the radar site. So
Yeah.
you don't know the range. Like it doesn't tell you where the cell tower is. It just gives you interference on that whole angular spread, and that's what you're filtering out, correct?
From Industry Canada, we can get location of a cell phone tower.
Right,
so
but not from your radar signature. I'm
no,
just curious
it's
why that
hard.
is.
Yeah, it's hard to from the radio RFI interference. You cannot tell the range of where the source is. It can go forever.
Right. It was mostly the Franktown site near Ottawa that was the worst I found.
Yes.
But
Yeah,
it's
but
so
it's
it's a lot
gone
better now. Yeah.
Yes.
Thank
yeah.
you. Okay, good talk. Thank you.
Yeah, thank you.
Okay. Any other question? Well, if we don't have any more questions, then the only thing left is to thank Quinn Lee for a very wonderful presentation, bringing us up to date on the new radar system.
Thank you for having me
And
here.
thank you for joining all those who joined. Thank you.
Thanks.
So this ends the webinar.